Welcome back. Last week we talked about how to create variables, and by that I mean we created timers and we created some programming that went to the timer, and we also started with score, but we really didn't talk about how you could use that in your game. So today I wanted to re-review what we did when we set up timer, which in yesterday's class we talked about timers were global variables, meaning they apply to everything that's happening in the game. Whereas yesterday we talked about when you create score, that's a local variable. Now it can be a global variable if you want you have just two characters and there's only one character scoring against another. But you can make score local, meaning that you have two characters that can get points when they touch something. That's a little bit tricky, but I'll show you here and I think it'll be more clear when you can see it in action. So, last week we talked about timers, and you can see here on my screen we programmed when you click the green flag, set timer to 0, and then you have to also then get your timer going, right? So you set when green flag is clicked, forever, wait 1 second, and change timer by 1. Because what makes these variables is that when you create them, Scratch automatically comes up with definitions that you get. Set, change, show variable, and hide variable. We talked about how variables are in Scratch are like how you would think about variables in math for those of you who have already started algebra, because variables are symbol equals a definition, right? So here you have x would be your symbol if you were talking about math, equals, and the definition is, say for example, 10 minus 7, so its definition is 3. Well, it's the same thing with Scratch. Time would be the same as saying x, right? Timer. And then what you define, whether it's set, change, show, or hide, is its definition, which would be the same as saying something like 10 minus 7. So it's something to think about when you're working in computer science. There is math, but it looks a little bit different, and it's nice in Scratch. They actually put it in English, so it's a little bit easier to understand what your symbols are and what you're defining. So anyhow, so last week we set up the changing the timer to setting it to 0, and we also had its definition of when it would stop timing, and we used the wait until and stop all. So that was basically how we set up our first variable, our global variable, last week. This week I'm going to talk about score, and I'm going to treat it as a local variable, so you can see what I mean in the difference between that, and then I'm going to show you an example of some programming for these Krabby and Cat Sprite and my little algebra equation are all going to be in a little tiny game here. So when you go to make a variable, you see you get this choice of naming it, and you see the choice down here. This is the important difference between global, which is for all sprites, and local, which is for this sprite only. When I created this score, I checked for this sprite only. I already did that, so I want to cancel out. So, and you have to do it for each of your characters if you're going to give them their separate score. So when I created Cat's or Sprite 5's score, I'm going to make it so you can see Scratch says, oh, it's just for the specific sprite. So I'm going to give it the sprite's name, which is Sprite 5, and then I'm going to call score. But you only define it as score. Okay, so you only have to type in the word score. And same thing for Krabby here. I've already gone ahead to save time, and I've clicked on here, typed in score, and clicked here. Okay, so when I did that, I got this little score tile, and I'm going to make it visible so you can see Scratch called it crab score. So easy enough. These are the local variables. This is where you have a game where you have two characters and they're each going to get a point, and we're going to program it so that when this x equals 10 minus 7 touches either crab or cat, their score goes up. So of course you have to have some motion, and we already talked about this in class, so I programmed it so the cat score moves when you press the direction keys, and I set Krabby here on a glide. So I don't think we need to go over that because I think everybody in class seems to understand that pretty well. What I did here is I also had this third sprite, the algebra sprite. And what I did with him was I had him follow the mouse pointer. And I think some of you have done this in class, but just so you can see here on my screen. I had him wait 2 seconds. When you're having a character follow the mouse pointer, it's good to have it hold on for a second, because otherwise, and also set him to go to a certain point when the game starts, because when you go, if you have him following the mouse pointer and you go to end your game, it literally follows you all the way up there and it will take him off the screen. So that's one consideration when you're using that control, that event handler, that motion there, excuse me. So anyway, that little aside there. So I've got him going and I've programmed it so, and you can go, the scoring programming is done on the sprite you're looking to get the point for. So if you go back to cat here, and you can see this is an example of the programming for using your new variable score, right? Change score by 1. So you're going to pull in 2 controls. Your forever, which I think you're getting used to seeing, so forever here. And then you have to pull in an if, and this is a new one from we didn't cover in the first 2 classes that we talked about last class. This is a new block. If, and you're going to have a little empty block socket here, then. Use this one, not this if then else. That's another logic that we may or may not get to in this session. So I pulled this over, and you can see I have it here, if. And then what I did is I went to sensing, because we want it to know, like, well, what happens? Who? So I grabbed a block here. If touching, I pulled it over. So I'm saying if this cat, sprite 5, is touching this algebra equation, which is called sprite 4, increase the score by 1. And you can see I did the same thing for Krabby. So the forever block here, and then you drag inside of it an if, a little empty socket, then I drug it over here, and then I went back to sensing and pulled over a touching, and of course it's the same sprite, right? Sprite 4, they're both competing to touch the same guy, and then I went back to the variable, which is score, and drug over change score by 1. Now you could do this one by one. The other tip I wanted to show you is that if you've got a block programmed and you don't want to have to pre-program it for another sprite, and it's the same logic, you can just drag this over and it will drop it. And if you let go of the mouse key, it will pull it over to your next sprite. So it's kind of a shortcut for adding programming, but in the beginning you might want to be careful and program one by one just to make sure everything goes where you expect it will. So let's take a look at this game. So you see, I click the flag. This is going to wait 2 seconds, and here's my little algebra equation, touching Krabby. Oh, see, score goes up. And let's see, touching little, whoops, sprite 5, and see his score goes up. So this is kind of a simple game. This is not the best game because, as we found out with Scratch, and see how he goes following the mouse pointer, I go to end the game, he goes up here. But because I've programmed it, when I click the green flag again, he goes to X and Y is 0, and he waits 2 seconds before he moves again. It gives you a little bit more control once you restart your game. So that would be the reason why I would do that. So it's a little bit of shortcut programming in talking about variables that I think the more you do it, the more it makes sense. So we'll keep talking about it in the next 2 classes because you guys are doing great. We've already got apps migrated over to App Inventor, and I couldn't be more proud because we talked in class that on average it takes 4.5 months for somebody with programming experience, an adult, to get an app started and ready to publish. So you guys in 4 hours of class time have already gotten some really nice rough drafts started. So I can't wait to see what we get done by the end of class. So in the meantime, keep on scratching.